I like to make a note, this is G. All that is G. G equal to some constant K. So let's use Lagrange multipliers. What's del B? So now when we're starting Lagrange multipliers, the first step, let's get del V, del G. We'll put a lambda with del G. We'll solve the system using the constraint as well. What's with respect to x? YZ. What's with respect to y? XZ. Good job. What's with respect to y? Z. Does that make it this partial derivatives? Okay, that's done. I love this part. What's del G? All right, now put the lambda in front of del G, right? Remember, del G, it's a gradient vector. It's a vector. It's the normal vector. To those contours you saw earlier. I love this. What's this? 1, 2, 3. This really here is what makes Lagrange multipliers pretty simple. Not every time. I mean, it's some nasty systems, but we have technology that can solve crazy systems and crazy as well. All right, this must equal this. This must equal this. With the lambda. Oh, let me put my lambdas. I got the lambda here. I got to distribute that lambda, right? So I'll put 1 lambda, 2 lambda, and 3 lambda. And xy must equal this 3 lambda, and then I'm also going to write that. So here's the system we're going to solve. Solve this system, we're going to be done. YZ must equal the lambda. And what else? XZ must equal the
2 lambda.
2 lambda. And XY must equal the
3 lambda.
3 lambda. And x plus 2y plus 3z equals 6. If you're curious why I keep writing and, I mean that's what it's, you've heard the words and, you've heard the words or in mathematics, it's and. When you're talking about a system of equations trying to solve, it's like that equation and that equation and that equation and that equation must hold true for all those variables. Okay, plus another reason I always write that, we used to use a calculator. I see some TI-84s on the tables. We used to use the TI Voyage 200. Have you ever heard of it? Feel free to Google it. You'll laugh at what it looks like. It's about this big. It looks like almost like a computer, you know. But that's the only thing was, it's like the TI-89. In TI-9, you have to type in the word A and D. You have to type A and D. Like when you had to solve the system equation, you had to go in and go A and D. Then we go off screen. You had to just keep typing all this stuff. All right. Hey, let's get started. There's different ways to solve a system. I'm thinking, and when you both have lambdas, you want to set these equal to each other? What would YZ have to equal? If YZ equals lambda, then YZ would have to equal what's lambda equal here? X0 or 2? I mean, it's one way to start, right? Can I set these two equal to each other if I solve for lambda in each case? That lambda equals YZ, this lambda would equal X0 or 2. Alright, what can I cancel out? The Z's? What's Y equal to? Alright, hey, I'm getting started. Y is equal to X over 2. You know, I could put that over here. So, boy, I'm almost there. When we can get this whole equation in terms of x's, we can solve for it. So I know Y is equal to X over 2. That's true, in terms of the relationship. Let's play with these two now. Let's play with those two. What would XZ over 2 have to equal? XZ over 2 would be lambda, and what would that have to equal? Solve for lambda here. XY over 3. What can I cancel out there? If XZ over 2 equals XY over 3, then knock out the x's. Z over 2 must equal what? Y over 3? So what's Z equal to?
2y.
Z equals 2y over 3. I'm getting closer. But when I wanted to get all x's. So any suggestions? Someone's going to see it. You are the best. I want to keep y. I'm going to put that in for the x right there. I'll have that x. But z was in terms of y. She says then just put this right there. So now what's z equal to? So z now equals, I'm going to write it again, 2/3 times x x over 2, which is now what?
X over 3.
And I'm ready. There's z. There's y. Let's put them in here. Right here, I'll just put it up here, right here. Let me write this again. X plus 2 times x over 2 plus 3 times x over 3 equals 6. And we'll have x. Now this comes out real easy. This is just what? X plus x plus x? 3x equals 6, right? X equals 2. Got one. So we have x equals 2. That's the length of x. By the way, if I want this to kind of go with this image here, maybe I can call like, you say, well, you got x going this way. Okay, your x equals 2. What's y though?
1.
How'd you get that y? You put it right,
Yep, X over 2.
right there? So x is 2. 2 over 2 is
1.
1. So this y value is 1. X equals 2. Y equals 1. And how do you get z?
1/3.
1/3, what'd you use?
X over 3.
Right over here?
Mm-hmm.
X over 3, 1/3. Hey, did I answer the question with the dimensions? Oh, it's 2/3. Thank you so much.
2/3, yes.
2/3. Because right here, x was
2, yeah.
2, so 2 times 1/3 is 2/3. These are the dimensions of the box. They asked for the what? They go give me the volume, so I'm just going to multiply all these. The volume would be what? 2 times 1 times 2/3 gives me
4/3.
thirds. That would be the maximum volume of wedge in that box. So there's a funny box in here where the corner hit this plane. And that was the constraint. Cool? That's it.